Every small company reaches the same moment. Someone emails a file to a colleague, the file is too large, the email bounces back, someone saves a document to their desktop, and a week later, 3 different versions exist on 3 different computers and nobody knows which one is current. Someone leaves the company and takes every file they ever worked on with them because everything was stored locally on their machine, and nobody thought to back it up. Someone works from home and not access the file they need because it lives on a computer in the office that nobody thought to leave turned on. These are not exotic technology failures. They are the daily friction of small companies trying to function without a centralized place to put files, find files, share files, and know that the files are safe. The Saluti. On that enterprise, companies have used for decades a dedicated file server that every employee connects to, that stores everything in one place, that handles permissions so the right people can access the right files, that backs up automatically so nothing is lost, has historically seemed like something that required an IT department, NT, to set up and maintain. It does not. With the tools available today, a small company can have a professional file sharing server running in under an hour without an IT department, without enterprise software licensing costs, and without the kind of technical expertise that used to be the barrier between small companies and the infrastructure that large companies take for granted. This is the complete setup. Every step, every decision, every configuration choice explained well enough that you understand not just what to do, but why you are doing it, so that when something needs to be adjusted later, you have the understanding to adjust it rather than the helplessness of someone who followed in Esther. Auctions without comprehension. By the end of this, your company will have a file server that your employees can connect to from the office and from home that keeps files organized in a shared directory structure with appropriate access controls, that backs up automatically, and that costs a fraction of what cloud storage subscription services charge for equivalent functionality. The first decision is hardware. Your file server needs to be a computer that is always on, always connected to your network, and dedicated to the function of storing and serving files. It does not need to be powerful. File serving is not a computationally intensive task. It does not require a fast processor or a large amount of RAM. What it requires is storage capacity, network connectivity, and reliability. The most cost-effective approach for a small company is a network-attached storage device, a NAS, which is a purpose-built piece of hardware designed specifically for this function. NAS devices from manufacturers including Synology, QNAP, and Western Digital come with their own operating system. As optimized for file serving, consume very little power, run silently, and are designed to operate continuously without the reliability concerns of using a general-purpose computer as a server. A 2-bay Synology NES device costs between $200 and $400 depending on the model and the drives you install in it. For a company of up to 20 employees whose primary use case is document storage and sharing, a 2-bay NAS with 2 4-terabyte drives configured in a mirrored RAID array, meaning both drives contain identical copies of all data. So if one drive fails, the other continues functioning without any data loss, provides 8 terabytes of raw storage and 4 terabytes of usable storage, which is sufficient for most small companies for years of document, spreadsheet, presentation, and image storage. If you prefer to use an existing computer rather than purchase dedicated hardware, any computer running Windows, macOS, or Linux can function as a file server. The requirements are modest, at least 4 gigabytes of RAM, a processor that is not more than 10 years old, and sufficient storage either in internal drives or connect. external drives for your file storage needs. A refurbished business-class desktop computer purchased for $200 and a pair of external drives purchased for $50 each is a functional file server for a small company at a total hardware cost of $300. The trade-off compared to a purpose-built NAS is higher power consumption, more noise, and a less streamlined administrative interface. For a company with someone comfortable with basic computer administration, a repurposed desktop is a perfectly functional approach. The network connection of your file server matters more than its processing power. The server should be connected to your office network router via a wired Ethernet cable rather than through Wi-Fi. Wired connections are faster, more reliable, and do not suffer the intermittent drops and speed variations that Wi-Fi connections experience. The cable run from wherever you place the server to your router or network switch should be a Cat6 Ethernet cable, which supports gigabit speeds that are sufficient for multiple simultaneous users accessing files. If the physical layout of your office makes a wired connection to key server's permanent location impractical, position the server as close to the router as possible and use the shortest Wi-Fi distance achievable. But understand that this introduces a performance and reliability limitation that a wired connection would eliminate. Once your hardware is chosen and physically set up, connected to power and to your network, the software configuration begins. The approach described here uses a Synology NAS because it represents the combination of ease of setup, professional capability, and reasonable cost that is most appropriate for the small company context. The principles apply to any NAS platform and can be adapted to a general-purpose computer file server, but the specific interface and menu names reflect Synology's Disk Station Manager operating system, which is what you will find on Synology devices. Power on the NAS and connect it to your network. From any computer on the same network, open a web browser and navigate to find.synology.com. Synology's device discovery service that will find your new NAS on the local network and direct you to its setup interface. Alternatively, the Synology Assistant application available on Synology's website performs the same discovery function. When the setup interface loads, you will be GUIDed through the initial configuration, installing the Disk Station Manager operating system onto the NAS, configuring your storage drives, and creating the administrator account that you will use to manage the device. The storage configuration step requires one critical decision that you should make deliberately rather than accepting the default without understanding it. When you have 2 drives in a NAS and you configure them in RAID 1, the mirrored configuration, you get the capacity of 1 drive with the redundancy of 2. If either drive fails, the other continues operating and no data is lost. When you configure them in RAID 0, the striped configuration, you get the combined capacity of both drives but no redundancy. If either drive fails, all data is lost. For a file server whose purpose is storing your company's important NT documents, always choose RAID 1. The reduction in usable storage capacity is the cost of the insurance against drive failure, and hard drives do fail. THE question is not whether a drive in your server will eventually fail. It is whether you will have a redundant copy when it does. RAID 1 ensures you will. With the operating system installed and the storage configured, create the administrator account using a strong password. A password that is at least 12 characters long, contains a mix of uppercase and lowercase letters, numbers, and symbols, and is not used for any other account or service. Write this password down and store it somewhere physically secure in your office. This is the e-master key to your file server, and losing it creates significant administrative complications. The next step is creating the shared folder structure that will organize your company's files. This is the architectural decision that will either make your file server genuinely useful or create a chaotic digital equivalent of the filing cabinet where everything gets stuffed in the front drawer. Think about how your company actually works before creating folders. The goal is a structure that is intuitive enough that any employee can find a file without asking someone else where it is, and organized enough that T-files are stored in the correct location rather than wherever was convenient at the moment of saving. A functional shared folder structure for a small company typically has a top level of departments or functional areas: administration, finance, sales, marketing, operations, human resources, projects, with subdirectories within each that reflect the actual categories of documents those areas produce and use. Within projects, for example, individual project folders named for the client or project, each containing subdirectories for contracts, correspondence, deliverables, and working files. Within finance, subdirectories for accounts payable, accounts receivable, bank statements, tax documents, and annual reports. The specific structure should reflect your company's actual operations, not a generic template. And it should be created with input from the people who will use it so that it matches how they actually think about file organization rather than how an IT person thinks about it. In Disk Station Manager, shared folders are created through the File Station application or through the Control Panel. Open Control Panel, navigate to Shared Folder, and click Create. Name the folder, set its location to the storage volume you created during setup, and configure the basic options. Enable data checks, some for advanced data integrity if the option is available. This adds a layer of protection against data corruption. Tie-in that has a negligible performance cost and a meaningful reliability benefit. Enable encryption only if you have a specific need for it, and understand the performance implications and the key management requirements. Encrypted shared folders require the encryption key to be mounted each time the NAS reboots, which adds an administrative step that is worth the trade-off for highly sensitive data, but unnecessary for general document storage. User accounts are the mechanism through which you control who can access which folders. In Disk Station Manager, open Control Panel and navigate to User. Create an account for each employee who will access the file server. Use each employee's actual name as the username, first name, last name as a format that is clear and consistent, and set an initial password that you communicate to them securely, requiring them to change it on first login. Organize users into groups that reflect your company's access control needs. An all-staff group that has read and write access to the shared folders that everyone needs. A management group that has access to folders containing sensitive information. a finance group with access to financial documents, and so on. Assigning permissions to groups rather than to individual users makes ongoing administration simpler. When a new employee joins, you add them to the appropriate groups, and their access is configured. When an employee's role changes, you adjust their group membership. When an employee leaves, you disable their account. Permissions in Disk Station Manager are configured at the shared folder level. For each shared folder, you specify which users and groups have no access, read-only, or read and write permissions. A well-designed permission structure gives employees access to everything they need for their work and nothing they do not need. The all-staff shared folder, the location for company-wide documents, policies, templates, and information that everyone should be able to access, gives the all-staff group read and write access. The finance folder gives the finance group read and write access and gives management read-only access, with NO access for all other employees. The management folder gives only the management group access. This structure ensures that sensitive information is not accessible to EMPL OEs who have no legitimate need for it, while ensuring that everyone can find and work with the files relevant to their role. Remote access, the ability for employees to connect to the file server from home or when traveling, is what transforms a local file server from a convenience into genuine infrastructure. Without remote access, your file server is only us equal to employees who are physically in the office. With remote access configured correctly, your employees can access company files from anywhere with an internet connection with the same experience as being in the office. Synology provides remote access through two mechanisms. The first is Quick Connect, Synology's relay service that allows you to access your NAS TXR, a unique identifier without configuring your router or requiring a static IP address from your internet service provider. Quick Connect works by routing your connection through Synology servers, which means it is simple to set up, but the connection speed depends on Synology's infrastructure. For most small company file access needs, opening documents, saving documents, browsing folder structures, Quick Connect speed is adequate. Enable Quick Connect in Control Panel under Quick Connect, register a Synology account if you do not already have one, and choose a Quick Connect ID that represents your company, your employee. These can then access the file server from anywhere by navigating to Quick Connect to your company in a web browser, or by entering the Quick Connect ID in the Synology Drive client application. The second remote access mechanism is a VPN, virtual private network, that connects remote employees directly to your office network as if they were physically present in the office. VPN access is faster than Quick Connect for large file transfers because the connection goes directly between the employee's computer and your NAS without routing through an intermediary server, and it provides a higher level of security because all traffic is encrypted end-to-end. Synology and NAS devices include a built-in VPN server package available through the Package Center. Installing and configuring the VPN server requires configuring your office router to forward the appropriate network ports to the NES, a process that involves logging into your router's administration interface and creating a port forwarding rule, which varies in its specific steps depending on your router model, but is documented for all common router models and resources, available online. Once the VPN server is configured, employees install a VPN client application on their computers and connect to the office network whenever they need access to the file server from a remote location. Backup is not optional. A RAID array is not a backup. RAID protects against hardware failure. If one drive fails, the data is preserved on the other drive, and the server continues operating. RAID does not protect against accidental deletion, against ransomware that encrypts your files and demands payment to restore them, against physical disasters that destroy the NAS along with BOTH drives, or against software corruption that damages files across the entire array simultaneously. A proper backup strategy requires copies of your data stored separately from the primary storage location, updated regularly, and verified to be restorable when needed. Synology's Hyper Backup application, available through the Package Center, provides a comprehensive backup solution that can back up your NAS to multiple destinations simultaneously. Configure at minimum 2 backup destinations. The first is a local backup destination, an external USB hard drive connected directly to the NAS that provides a fast, immediately accessible backup copy that can be restored quickly in the event of a loss. The second is a remote backup destination, a cloud storage service or a second NAS at a different physical location that protects against physical disasters affecting your office location. Synology's Hyper Backup sub ports backing up to Amazon S3, Backblaze B2, Microsoft Azure, Google Cloud Storage, and several other cloud storage providers, as well as to RSync-compatible remote servers and to other Synology NAS devices. For a small company with 4 terabytes or less of data, Backblaze B, 2 Cloud Storage provides the combination of low cost, approximately $6 per terabyte per month, and reliable performance that makes it the most cost-effective remote backup destination for this use case. Configure Hyper Backup to run automated backups on a schedule that reflects how frequently your data changes and how much data loss is acceptable. For a company where employees are creating and modifying files throughout the business day, a backup schedule of once daily, running overnight when the server is least busy, provides a recovery point that means at most 1 day of work could be lost in a worst-case S scenario. Enable versioning in Hyper Backup, which stores multiple historical versions of your backed up data rather than just the most recent version. Versioning means that if a file is accidentally deleted, or corrupted, and the damage is not noticed immediately, you can restore a version of the file from before the damage occurred. Configure versioning to keep at least 30 days of backup history, enough to recover from situations where data loss is not discovered immediately. The client-side setup is what your employees interact with daily, and making this experience as smooth as possible determines whether the file server actually gets used consistently, whether employees revert to emailing files in Savvy to their desktops. Synology Drive is the client application that provides the file server experience on employee computers. It maps the shared folders on the NAS as network drives that appear in Windows Explorer or Mac Finder, exactly like local folders, allows offline access to files that are synced to the local computer when a network connection is available, and handles the synchronization of changes when the connection is restored. Install Synology Drive, client on each employee's computer, configure it to connect to the company's NAS using their individual credentials, and map the shared folders they have access to as network DRIVs with consistent drive letters or mount points across all company computers. Using the same drive letter for the shared folder on every computer means that document shortcuts and application settings that reference file paths work consistently regardless of which computer an employee is using. Security hardening is the final configuration step that separates a properly set up file server from one that is functional but vulnerable. Enable the firewall in Disk Station Manager's control panel and configure it to allow connections only from the IP addresses and ports required for legitimate access, blocking all other inbound connection attempts by default. Enable the account lockout protection that automatically block of failed login attempts. 5 failed attempts triggering a 30-minute lockout is a reasonable configuration that stops automated password guessing attacks without creating significant inconvenience for legitimate users who mistype their password. Disable the default admin account after creating your named administrator account. The default admin account with the US. Our name admin is the first thing automated attack scripts target, and disabling it eliminates that attack surface. Enable HTTPS for all web-based access to the NAS management interface. Disk Station Manager can obtain a free SSL certificate from Let's Encrypt through its built-in certificate management, which encrypts the connection between your browser and the NAS interface and eliminates the browser security warnings associated with self-signed certificates. Update Disk Station Manager whenever updates are available. Synology releases regular security updates that address vulnerabilities discovered in the operating system, and applying these updates promptly is the single most effective ongoing security measure for your file server. Configure automatic update notifications in the Update and Restore section of Control Panel so you are informed when updates are available, and establish a routine of applying them within a week of release. The total investment for this setup is approximately $500 to $800 in hardware, a 2-bay Synology NAS device, and 2 4-terabyte drives, plus approximate ELI, $6 per month for remote cloud backup storage. The one-time hardware cost is recovered in less than a year compared to the subscription cost of cloud storage services, with equivalent storage capacity and user counts for a company of 10 or more employees. The setup time, following the steps described here, is under 2 hours for someone with basic computer literacy. The result is a professional file-sharing infrastructure that gives your company centralized storage, appropriate access controls, remote access capability, automated backup to multiple destinations, and the organizational foundation for keeping your files findable, secure, and protected against the hardware failures, accidents, and disasters that make ad hoc file management expensive and stressful. Your employees will connect to the server on their first day. They will find files in the shared folders where they expect them to be. They will save files to locations that their colleagues can access. They will work from home and have the same access to company files as when they are in the office. The version control confusion, the email attachment chaos, the lost files on departed employees' laptops, the daily friction that small companies accept as normal because it seems like the cost of not being an enterprise, will stop. Not because you hired an IT department, because you spent an afternoon setting up infrastructure that should have been in place years ago and was not because nobody told you it was this straightforward. It is this straightforward. The server is ready. Set it up today.